I've got my chat closed, so just interrupt me by waving if you want to stop me. I'll send you slides if you want it, feedback, and let's just not share this right now until we get back. Maybe Master Glenn will help me figure that out. Here's the title page. There's 3 representations of the pillars. Maybe you recognize study there, and you might recognize service and meditation, devotion to the teacher and teachings, and purification. I just thought we should just go ahead and announce that because it's awesome. Okay, so here's from the Miracles Through Pranic Healing Practical Manual on Energy Healing. Intelligent person is not closed-minded, not gullible, doesn't accept things blindly. He studies and digests them. He tests new ideas and developments through experiments. Intelligent person studies these ideas with a clear, objective mind. And to me, this means that we are to keep up with scientific inquiry related to prana and its behavior. So that's what I think we're trying to do right now, is keep up with it and go with the new scientific stuff. I wanted to propose a mindset in our group to understand that I'm not showing off with knowledge. In fact, some of you have more experience and study in the subjects I will review today than I do. So special thanks for Master Glenn to introducing us to each other last summer in Maui. Let us work together. It's still intro stuff. Oh, here's my balls here. I have to move them. Okay. MCKS tried to reduce the gap between science and spirituality by using experimental process that were essentially scientific in nature. Again, what we're trying to do. And the advances we have made in quantum physics have implications on our prana study and practice that are worth a few minutes, which is what we're doing right now, to understand. So here's my table of contents that I sent you guys. We're going to go through a couple of misconceptions in science, a few must-knows, the philosophical foundations of the arguments in quantum physics, because if you don't know the background, the more you know the background and the foundations, I feel like the better you can discuss it with other people. When you run into other physicists and other smart people, you want to know what you're talking about and how scientific research is approaching reality today. Oh, wait, the guiding principles of quantum physics and how scientific research is approaching reality today. Then I've attempted to relate these topics to our work with prana. My goal today is that the information is useful to the QPPS team and that we move forward in our research. So we're going to study the objective reality for a second, how things really are at the macro level. Macro level in physics includes everything except atoms. Microorganisms like bacteria are macro level objects in physics. So micro level means atoms, micro level in physics means atoms, subatomic particles, protons, neutrons, electrons, photons, and all the other ones that when they smash them up. The objective reality, this is what I always say when I'm teaching physics. The objective reality is the reality that when you jump off of a 14-story building, you splat on the sidewalk. That's what really happens. That's the objective reality. Oh, I have a demonstration here. We're length, width, and height. I have to hold it up, right? So this is X, Y axis, and the Z axis goes into the board that we always say. So length, width, and height axis are the 3 dimensions that we live in. But, decades ago, we realized, well, we don't live in 3 dimensions. We live in 4 dimensions because this is the event, this little floating heart here. And the floating heart is time. So wherever we can graph this guy on the Cartesian plane with the Cartesian coordinates, it's not existent unless there's time. So when we take time out of the equation, there is no anything. There's no dinner, there's no dentist appointment, there's nothing. So we have to have time in our equations here in the objective reality. Quantum particles don't obey the laws of objective reality, and that's what was really bothering everybody for decades. Why don't quantum particles obey the laws? Because they're not time bound, and that's like prana. Physicists recognize many dimensions beyond our 4-dimensional space-time that I just showed you mathematically. We call the first one, the first local dimension, operates without time in the equations that govern it. This is the form, this is from where angels, that's what we say in physics, angels, and they say sometimes ghosts, can materialize to us. They can be here and there and everywhere in the same time, like holy masters are when they incarnate here on earth or are incarnated, and others. So then we have the subjective reality that you're probably already thinking about. That's just as much real, but it's the one that's inside your head and convinces you that you can fly off that roof, right? Because you ate mushrooms or something. When the subjective reality doesn't match the objective reality, Relativity needs to be considered in human experience. Like, why not? What's different? For example, when machines don't function, the first thing you do, check the connection. In humans, you check the neural pathways, limbic dysfunction in the brain, etc. The second thing you check is operator error in machines. And for humans, then we can check the environmental variables like sleep, sight, biochemical dysfunctions, all that stuff that you know more about than I do. One of our research goals is to document statistically significant, reliable, and relevant data supporting the existence of prana as a tool for healing and other uses. We must be sure and always checking our method to expose the subjective reality variables and to maintain an objective scientific research point of view. So the objective reality rules still apply in the macro world, the one we live in, whether contrived subjectively inside of our head or measured objectively. Physical matter is only part of the objective reality because, well, you can see this picture here. The two guys are arguing over it's a 6 or a 9. So let's see. Now we've got the 3 principles of the objective reality: common sense, intuitive ideas, rational thought is like math. Cause and effect, we call causality. So I'll be using that word causality. It's cause and effect. Is not karma lifetimes of cause and effect to some extent? If so, a logical question for non-believers in karma is, do you believe in math? Light speed limit, you know what that is. It is lowercase c. It's lowercase c equals 300 million meters per second. The matter energy conversion equation, E equals mc squared, uses C, something like if you get matter or mass vibrating at the speed of light, like this, vibrating at the speed of light times the speed of light, this is matter, then it poofs changes to energy. That's kind of like what the idea is with that E equals mc squared business. Okay, so now locality is local causality. So locality is another word that is used in quantum physics all the time. Locality requires time in the descriptive equations. Cause and effect in the objective reality requires time from the incident is the first, the incident measurement, to the resultant, what happens later, measurement. So we use prana and it's cause and effect. So prana has a causal effect on the objective reality, but speed of thought is instantaneous. We know that with no time needed. So people who are non-believers in instantaneous action at a distance, you could say, do you believe in thought as, you know, it's so fast, right? And then there's the third one is inference. Maybe you already know what that means. It's like the sun rose today, so it's going to rise tomorrow. It rose 3 days ago, so it's going to rise 3 days from now. Inference is different than causality. It's the famous quantum physics cartoon, Dr. Bertelsmann here, that John Stuart Bell wrote. It was his friend at CERN in Switzerland, the big particle accelerator lab. So Dr. Bertelsmann was known to have a big sock drawer with his socks that he didn't pair. Does that ring a bell to anybody? So if you see Bertelsmann coming around the corner with a pink sock on one foot, you can infer that his other sock is not pink. And we rely on inference, rational thought, and light speed limit every day, like at a stoplight. You believe they're all going to stop. So now the Bohr model of the atom in the little print says not really how atoms are. It's just a model that works, by the way. So I'm going to show you how the Bohr model first is, and then why it's not really how it is. So all matter is made up of subatomic particles. And that's what really bothers the physicists. If all matter is made up of subatomic particles, then why don't the macro objects obey the rules of quantum mechanics? We need different rules for subatomic particles and photons than the rules we use for quantum objects like bouncing balls, teeth, and the space shuttle. The new rules for subatomic particles are called quantum mechanics, and for macro objects, the rules are called Newtonian mechanics or classical mechanics. Mechanics is the term used for the math that we use to put it all together. Math is a tool of science. We may discover that prana follows some or all of the same rules as subatomic particles or not. From a physics point of view, the MCKS healing protocols are indeed the mechanics of pranic healing right now. And I don't know if they're getting like more refined, you know, if they're being written more and more or added to or not. I don't know about that. So here's the model of carbon, common compound in the organic arena. The Bohr model, that's the Bohr model. of the atom works great for chemistry. That's why we use it. We teach it in textbooks. In the Bohr model, the electrons are constantly moving around in the nucleus of the atom. They're moving around in different orbits. Carbon has 4 electrons exposed on the outer, so they bond really easily and make long carbon chains. They bond, they bond, they bond. And that's what organic molecules are made of, and so forth. There's just boron. It's another one. So electrons are always paired, one spinning up, one spinning down. They're always paired, and this is an important thing. Master Glenn, I know you already know about this stuff because we talked about it. But anyway, so if I'm going this way, they're spin up and down. So can you see this white arrow? If this is an electron, see the white arrow? This is spinning up. If the angle is this way, if the axis angle is this way, if the axis angle is this way, it's still spinning the same way. But look, it's spinning down now. So we have axis angle. Let me just go ahead and show you because you're going to look at the experiment soon. 30. 60, 90 degrees spinning up, 30, 60, 90 degrees spinning down. That's going to be a big experiment that we have to look at. Okay, so this is nature's way to balance, which is really important, I think, to us using prana. When we pushed the hurricane off of Maui, remember, you guys were all there, we did not move it across the Atlantic Ocean to the UK. That might have caused too much imbalance in the global weather system. We moved it just enough so that we could get home via car or airplane. That's what I thought we were doing. Moved a little, Master Marilog checked, we moved it some more. Does healing, actually changing molecular atomic state in the human body, respond better to repeated small changes rather than a large force of prana directed specifically at the cells in the need to maintain life homeostasis or balance? Example is radiation treatment. Small doses, I guess, right? Again, I don't know what I'm talking about. That said, miraculous healing occurs every day, right? Big healings occur every day. I've had 2, 3, 4 times, and the healing does not kill the body. Can we say prana brings the molecular atomic state into the body, into the human body back to balance if the body can absorb the amount of prana needed to heal without upsetting the overall life homeostasis? That's the thing. Okay, now here's how it really is. Puffballs. Electrons don't really move in orbitals. You might remember this also from chemistry. They move in 3-dimensional puffballs like in the top right. The inner first 2 electrons always move around and are found in the first puffball in the center of the atom called the s orbital. But again, this puffball represents the highest likelihood or probability of finding the first 2 electrons in the round puffball anywhere. The electrons actually can be found anywhere moving around the nucleus of the atom. The second ring of orbitals or electrons are found in the p orbitals, and the p orbitals look like flowers. I just have to keep going, guys. Okay, so 8 electrons, 8 protons. This is the atom of oxygen. And there's the purple set has 1 and 2 up down spin. The pink has 1 and 2 electrons up down spin, and etc. From these models, you can see that the atoms, what everything in the objective reality is made from, is mostly empty space. And we talked about that before, Master Glenn and I. Atoms make up all physical matter with mass. So all matter, everything physical, is mostly empty space. That statement begs the question, what is the empty space? Is it prana? Researchers are identifying the empty space as dark matter, which is not a really great name for prana. Theoretically, one could take a super long, thin wire, let's say of titanium, because it's pretty strong, single atoms at a time, and whip it through you guys and my computer and everything in my house and all that stuff. And it wouldn't change anything because it could be moving through the empty space in the atoms. This is why quantum equations may someday develop the mechanics for humans to walk through walls, while some of us are bouncing off the walls, holding tight to the form. A reality of the matter being mostly empty space is that prana allows a body to travel, or an etheric body to travel instantaneously and materialize etherically or physically, depending at some distance, to interact with or drop into real-time scenarios for interaction or observation. I don't know if you guys have experienced that. It's like astral travel or more, right? You know, that's a whole nother topic, right? So, but we've got that in physics, in quantum physics, because it's mostly empty space. So why not? Especially with the etheric body, go in and look at stuff, remote viewing. Okay, now, just to make sure you understand the electromagnetic spectrum, and just everything we see is just here. It's a little, I don't know if it's clear for you guys, but All light travels at the same speed, c, lowercase c. Red light has a lower frequency, higher wavelength. Blue light has a higher frequency, lower wavelength. And that means in one time second, a second, here's red light, light. 1 second, here's red light. 1 second, here's blue light. And then it goes, you know, from red to blue. So 1 second, red light, 1 second, blue light. Oh, blue light like that. So obviously blue light's more energetic because they all travel at the same speed, but blue light has a lower wavelength, higher frequency, and red light has a longer wavelength, lower frequency. Blue light's up here, red light's down here on the chakras, right? Blue light's more energetic, more energy means actually hotter. That's why the body must be ready to handle the higher chakra energy vibration in the blue, or else the head of the brain could literally fry or blow up. So when the masters are talking about you're not ready or we're not ready and you have to take it slowly, this is why. Because if you really got that higher vibration up there, it wouldn't be really healthy for, it wouldn't be healthy for anybody. On the blue end of this visible spectrum, you find UV. So we've worked out that too much UV causes skin cancer by repeatedly frying the skin. Gamma rays are also over there, and they're the ones like in nuclear explosions, deadly to living cells, and X-rays also are not healthy. Those are all beyond the blue, faster than blue, more frequent than blue. On the red end of the spectrum is radio. Radio waves can pass through the body without harm. And you can see, so the visible spectrum is demonstrated by holding a small flashlight into your mouth. I'm going to do that. You can see the light through your cheek, and it doesn't hurt you. So anything lower than that doesn't hurt you. Microwaves don't hurt you. Look, you can see the light through, and it didn't fry my. It didn't fry. It doesn't hurt my cheek at all. So infrared is over there also, and that's real like heat. Infrared, it's really red, and infrared and microwaves are lower energy than even the visible spectrum that I just showed you. So microwaves really aren't harmful in the same way that UV rays are, that they destroy you. Microwaves just raise the temperature and boil. They use water to boil, right? So microwaves can boil you. But anyway, prana is not electromagnetic. That's what I think. I think that's what I've learned. That's why EMF meters don't register prana. But we know that prana does carry visible light frequencies, right? And that prana travels at speeds faster than light. This has got a limited speed of c, right? So prana is not electromagnetic. It's not like really at the super high end. Non-electromagnetic prana is described as super ultra high frequency, being able to instantaneously travel. So it doesn't have any speed limit. Have you heard the masters talk about the subtleness and refinement of prana? It's really hard to describe. I know that I don't quite understand it. That's why I'm into this research. We know prana is not time bound. Okay, the red sine waves here represent the electric field, and the blue sine waves are just like that. The blue sine waves represent the magnetic field. So an electromagnetic field looks like that. And I just got a couple other pictures, look like this. And I thought I had a note that they spiral like this black picture. They spiral. They spiral when they move through, you know, like when the sun gives us light or any light, it's not just like this. It's actually, the whole thing is spiraling. That's an electromagnetic wave. Okay, I don't know, I must have deleted that little note. Anyway, okay, so understand this as a misconception. Red light is vibrating slower, blue light faster, right? Red light, blue light in 1 second at the speed of light. Green light vibrates in the middle. The red paper on the picture on the right is actually reflecting light, red light. That's why we see the red light. The red paper itself is actually absorbing all the other colors. The paper itself is absorbing all the other colors, including blue, and is therefore made of all vibrations except not red. So the red paper is vibrating really fast because it's not absorbing the red, it's reflecting the red. The red paper material is actually vibrating in all the colors, frequencies, including blue. Red paper vibrates fast. Red cars appear to be going faster and get more tickets. Wearing a red tie makes the speaker appear more energetic. Wearing white or white car reflects all the colors, absorbs no light, and is therefore the lowest energy and cooler. Reflects all the colors, absorbs no light. Black reflects no light, absorbs all the colors, and is higher energy and hotter. So this is impossible to take notes on this stuff. All color, it's just, I'm going so fast. All colors of light make white. All colors of paint make black. I'm trying to show you the difference between light and paint colors. Wearing orange, like the Tibetan monks, reflects yellow. If you look at the red paper, reflects yellow, orange, and red. So we see orange. The monk's orange shirt is actually vibrating at the higher frequencies of green, blue, and purple. So the monk is wearing a green a thing that's vibrating at a high frequency, but it's reflecting all the other ones. That's why we see it, because it's absorbed the higher frequencies. Blue color paint is cool because it's vibrating. The paint itself is vibrating at red. The blue paint itself vibrates at lower frequencies of red because it has absorbed all the red and reflects blue. What we see, red color paint is hot. The red paint itself vibrates at higher frequencies of blue because it's absorbed all of the blue and reflects red, what we see. Okay, so just review. This is actually vibrating really fast and reflecting red because we see the red light. Okay, and this one is supposed to be blue. I didn't have a blue tennis ball. Is actually vibrating at a low frequency because we see blue. And this one is really, really low because it's reflecting everything. And when we see all of the colors reflecting as light colors being reflected, that's white. That's why we see it as white. So that's something I don't know when they actually teach that, but that's something that I think we just need to be careful. I thought I talked about that somewhere. Oh yeah, at the end. Okay, so the Doppler effect, I think is important for prana because kind of works like prana, maybe, or why we know the universe is expanding, a redshift. Okay, so we've got the car here continuously honking at a normal sound like beep, beep, beep. And then the observer at the red arrow, here's the low tones, beep, 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 as it's spread out and the frequency spreads out and makes a lower sound. And then the observer at the purple arrow here's beep, beep, beep as it's coming towards you. So the Doppler effect works for sound and light. This is a picture of sound. Einstein actually developed this idea of the Doppler effect when thinking about relativity. And you can see because it's all relative to where you're standing. This is why we know our universe is expanding or moving away from us, because the wavelengths of the distant stars systems are shifted to the red. That's what we say, shifted to the red end of the visible spectrum, indicating that they're moving away from us, as if the Earth was the red arrow where we are, and our universe was the car moving away from us. So just prana, and I call prana field, you know, the field, prana field, behave this way. It's an interesting idea. Causal energy can be the energy of photons or light or prana. And we know prana is causal because we do stuff and it changes. It's cause and effect. Exercise, being out in the sun, emotional outbursts, positive or negative, absorbing prana and other experiences can increase the overall excitation of atoms, compounds, cells, biological tissues, and organs. All right, so this is just, don't get too involved with trying to look at every little detail, but the one with the yellow centers are neon, and the ground state is on the left. It's smaller, and the excited state is still neon, but it's more puffed up. And the electron does not have to stay where you normally find it in a Bohr model, like shells, 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 like how we learned. The jump, it doesn't have to stay there. The jumping around of the electrons, like in the pictures, does not change the atom from nickel to gold, for example. It stays neon. Quantum leaps change the state of the atom from the ground state, jumping up to the excited state and back down to the ground state. As you can see, the excited state's bigger and more puffed up version of the same atom. So I think I have another thing. Yeah, this is the better picture. So when an atom absorbs the photons, the squiggly arrow going in, light or prana, it's in the excited state or more energized. And then let's see, I have notes here. When the energy is absorbed by an atom in the upper squiggly arrow, the inner electrons jump out to the next higher energy level. And if there's no energy level there, they make one. They make a new energy level. They get bigger, like in a petal or in another round ring or something, but it's all probability distributions anyway. The atom subsequently gets energetically bigger. This is the atomic excited state, which lasts only a little more than a nanosecond. I think when we're jumping around doing our exercises and then we go and meditate, I think that that's what we're doing, is we're puffing up our atoms so we can absorb. When an atom emits energy, it gets bumped, for example, just around town or something. The outer electrons fall down into the lower energy state. This is where the ground state is and where all atoms are at their lowest energy. So we're trying to be at our highest energy in the excited state. When prana is projected onto a living cell, do the cells go into the excited state and continue to remain there as long as prana is being projected? Because they only stay there a little bit, but as long as we're projecting, do they stay there? Does this cellular excited state help ramp up the chakras? Do human cells go into an excited state during meditation? And if so, for how long does that last? Do holy masters walk around in an excited state, thus making the edges of their form appear bigger and more translucent? Does an excited state allow prana to be absorbed more deeply after exercise, and if so, for how long? Okay, so now you know that. Now here's another misconception: the water hose model to explain electricity flow. It's incorrect, but it's what's in the textbooks. So the model generally says that electrons flow through the wire like water flows through a hose. This is incorrect. You don't have to, memorize this or anything. The flowing water in the hose is the current. The twisty end of the nozzle where you adjust it is the resistance. And we talk about resistance in the conductivity prayer. So as long as the spigot, which is the cranking part, is turned on, the water keeps coming. That's like the voltage from the well or the source. And the water hose model of electricity is in textbooks, but it's not the way electrons move or electricity works, actually. So it's the quantum jumping model of electricity flow that you already know about. So interesting fun fact: electrons flow through a copper wire slower than a snail's pace. Nobody believes that one, but electric current is the result of a chain reaction from one electron to the next rather than a constant flow. So this picture of lightning coming out of the wires, that's not a bunch of electrons, that's just energy. The electrons in the copper wire aren't flowing out like you see in amps in a bucket, and here's the electrons flowing out. It's not like that at all. This is what I want you to understand. The reason that, electric current is the result of a chain reaction of energy jumping from one electron to the next rather than a constant flow. Oh, I think I just said that. As so much electron energy jumps out of a copper wire because the wire is thick or has many twisted wires. Thus, the electron's energy doesn't jump single file, otherwise it'd be at a snail's pace. So I made this with my little arrows and stuff, showing the electronic energy, not electrons, but electronic energy jumping through a wire of atoms, jumping in a line through a wire, right? So the wire has got all the pluses, those are like copper. Each purple electron that's got the minus sign in it is a different electron, not the same electron. The black arrows are showing the energy of the electron, the puffball, jumping from one electron to the next at a snail's pace. That's why, I think I said it somewhere, but that's why, maybe it's next. Now the electrical current flows out of the wire. It's just the energy of the electron being pushed out of the wire, not the electrons. Otherwise, the copper wire would be losing all of its electrons. And the power company would have to be pumping electrons all the time, but they're not. They're just pumping the energy. The power company is pumping more energy into the wires to replace the energy coming out. Not sure what the distinction is between electron, a puffball of electron energy, and electronic energy. Here's a flashlight experiment. Turn a flashlight on in a dark closet. Leave the flashlight on in the closet, shut the door, walk away, come back in 10 minutes. We assume that if the electricity was flowing or the electrons were flowing out of the end of the flashlight, wouldn't the closet be full of light?
Zora Krupta has a question.
What?
I had a question on the previous slide, if you don't mind.
Go back? All the way back?
No, just one, the copper wire one.
Oh yeah, okay. Probably I can't answer it, but what? Go ahead. This one?
Yeah, here. So in that bottom figure, does that mean that each one of, so first of all, first question, is this different molecules? So different copper molecules?
This is, yeah. The pluses are a copper molecule, copper molecule, copper molecule. Yeah.
Okay.
So it's
So-
not like the electrons are coming out where all the arrows are. They're not coming out in a bucket because they say the bucket is the amps in the water hose model. So it's not like that. It's just the energy is the black arrow. The purple dots are the electrons with a minus sign. And the energy is just, oh, too much energy here. So jumping there, too much energy here, jumping there. Is that it?
Yeah, and so is that related, is this related to the activated state that you talked about in the previous?
Yeah,
section?
it's the same way. It's showing
Okay.
that how electronic energy, how
Okay.
energy jump can make an atom can move around. Energy is everywhere,
Got it. Okay, thank you.
right? So that's what this flashlight experiment is about. The only lit up area, what we find, what the result is inside the closet is where the electrons can jump to the next particle in the air, the electronic energy, add energy and excite the air atoms to light up. Okay, so light has the ability to overcome darkness with a little push and must be adjacent to the darkness. Wait a minute, let me go back to here. Oh yeah, okay, so this is an example I read of a classical or Newtonian physics, specifically optics, that I read in the Mishnah, where rabbis commented on the Torah about God's light and the ability of God's light to be everywhere and to overcome darkness. We can see the colored prana coming out of a palm, right? I've seen it. You can see it. Can we light up a dark closet with white prana? Prana is not electromagnetic, but it's a carrier of electromagnetic energy. It's a carrier of light. Does all the dark closet need to overcome the darkness as a little push to get that energy moving? Because it's already there. Could we achieve that with prana? Prana is everywhere. God's light is everywhere. The ability to overcome darkness is everywhere. Okay, this is resonance now and why group meditation and group healing is better because of resonance. This is just a picture of an oscillating spring showing that an oscillating spring, a pendulum, or any vibrations also mathematically create the sine wave, and sine waves are shown here. These sine waves shown here have the same wavelength and the same frequency. The amplitude is from the, can you see my cursor? No, I don't, no, you can't. The amplitude is from the line to the top, and the wavelength is from crest to crest, and the frequency is how many wavelengths in 1 second. 1 second red, 1 second blue, right? So now, here's the scientist doing that experiment that we probably all did in 6th grade or something with the tuning forks. He's hitting the tuning fork on the left. The scientist is creating resonance by hitting the tuning fork on the left to make a middle C sound, if that's a middle C tuning fork. And by resonance, the other tuning fork on the right starts to vibrate and make the same sound without even touching it. You can create sound resonance with a piano and a guitar. If you've ever done that, place a guitar near a piano, push the piano foot pedal so it continues to vibrate, to releases the vibration for free vibration. Strike the middle C key on the piano and the guitar middle C will start vibrating and make a sound. So now you have a guitar and a piano making both vibrating at middle C, and you didn't touch the guitar. That's resonance. That tells us that people nearby who are seeking the resonant vibration of the higher self, like in group meditation, will experience a spontaneous rise in their vibration by the fact that they are near a group meeting or chanting. Doesn't that sound right? And we know that this is true when we feel the vibe inside of temples, cathedrals, or other holy places. We also feel the frequency lift or the amplitude lift when we are merely standing around others, right? You get close to the masters and it feels pretty good, right? But there is more to resonance that's important. There's more. Okay, so this is just showing you, I want you to see this word resonant frequency and system resonance. That's what we're doing when we group meditate. When a system of the same frequencies, they're all the same frequencies, like we're all doing the Diane, are measured, an increase of amplitude is found. It sounds weird, but the coherent meaning all the same, in the same coherent waves with same frequencies and wavelengths will produce a wave with increased amplitude. and other waves of different wavelengths and frequencies could interfere destructively and decrease the overall vibration or even flatten them into what we call standing waves. Resonant frequency and sound resonance are applicable in our group meditations. The sciencey parts of MCKS pranic healing likely had something to do with your attraction to the subject. It did for me. I think it's fair to make an assumption that the general population is ready for the facts of resonance as it relates to group meditation as we move into the new age and more brainiacs are incarnating every day. Okay, this is what I really want you to know. This is showing you the red sine wave is showing the increased amplitude. The incident wave is the first one coming. The paper there is the reflecting, and it reflects off and makes the same wave, and it's showing the two waves increase the amplitude. And again, we just don't know why. Like 2 + 2, if it's 2 up, it's 2 + 2 = 4, instead of just staying at 2. So that's showing the reflection wave. They're talking about incident wave, reflected wave, and resultant wave. And then we're trying to get system resonance in our group meditations and resonant frequencies. This graphic shows the exact reflection. I already went over that, and the resultant red wave. So if a room full of our Arhatic Yogis doing MCKS Arhatic Dhyan, which is easy to hold and focus because of the sound, there should be little destructive wave interference from non-focused thought vibrations and thought forms. The overall resultant wave energy in the room will be greatly increased. The amplitude won't be increased due to the mathematical resonance beyond the incident wave, which is Master Choa's voice, carrying the meditators up beyond the crown, for example. Resonance increases the amplitude or the power or the energy of the wave. This is not a frequency increase, so it doesn't do this. That's not going to fry your brain. And it's not a wavelength, not shorter increase. If it was a frequency increase and somebody was sitting in the audience, it would be dangerous to them because it would allow their physical bodies maybe not ready for the higher frequencies to become damaged. So that's why we do only certain things at certain levels. I think some people need to know the science behind it. We basically raise the amplitude or power at the Maui retreat when we reached out with combined channel prana to the hurricane and moved it offshore. We had a lot of power because we had a lot of people and the amplitude was raised. It was easy to do in a group. Master Marilag reminded us to use love, not will. I don't know if you remember. Can you imagine the importance of group work and the possibility of creating prana fields or auras that physically affect others in the environments of planet Earth at great distances? So we're just learning how to do it. Like we're just learning how to move hurricanes. Oh, I should have had a graphic here for you. Why quantum mechanics fail every test of Newtonian mechanics.
Laura, I think Allison has a question.
Oh, I'm sorry. I thought there was something over there. Yeah, what is it?
Thank you so much. It's a little hard to see my hand actually against my background. Before we
do it in front of your face. Sorry, go ahead.
Okay. Before we leave the topic of resonance, and this is a really great presentation, by the way, absolutely great. And the topic of resonance, absolutely. I mean, yes. And because it is so fascinating, that's why I have this question. Absolutely, we do come into resonance with others. Do you have any thoughts on what it actually is? Like if we were going to measure that resonance, what would we be measuring? Would it be our thoughts, feelings? But of what? But of what? Would it be the thoughts?
Oh, well, that's what we have to get sensitized to. Yeah, okay, so there's a thing at the end, like what can we do? Let's keep going, okay? Yeah, I've got the same questions, that's why I'm into it. Newtonian mechanics does not work for quantum particles, but why? Bouncing balls are made of nothing but subatomic particles. Does the problem lie in our inability to let go of the form? Speaking of form, we know that if we take apart the components of a computer circuit board and put them in a shoebox and leave it for 1 week, and then we open the box, the circuit board will still be all messed up and separated, and the original form of the computer is nowhere to be found. But when we smash an atom into its subatomic particles and leave it alone, it really quickly will find its way back to its original form. So that's something that quantum particles do. And prana is thick or it's light, so it does its own thing. This is due to the 4 forces of nature that we're not going to go over Okay, so, oh, pop quiz, sorry, just for fun. From At the Feet of the Master, 3 questions. Where do you find things that are worth gaining? I'll give you the answer. On the path. And what's outside the path? All things unreal and unlasting. And where does the path lead? To God, to what is real and everlasting. So this is an example of how people have been questioning reality for millennia. And to understand quantum physics, you must be able to have thoughts on what is real and unreal. That's why I put that in there. Okay, deeper look at reality. We're going to go through this it's just basic stuff and then get into the more of the quantum physics. Local realistic theories, the ones we live in that describe the objective reality, are knowable in these 4 categories. You might have seen them and you could see, oh, that's philosophy, nature of reality, epistemology, relationship between the known and what is known, axiology, what we value, methodology, the strategy, or like how we do stuff. Okay. There's a nice little thing I made that shows we work in all of them. We think, oh, we just work in the cosmic realm. Yeah, well, yeah, we do, but we also work on all these levels. If you check it out, we work everywhere. So we're all, us Arhatic Yogis, we're all over the place. Okay, now the double slit experiment. Understand this is I think it's pretty important. Yeah, okay, a demonstration that light and matter. So here we go with matter. Matter can display characteristics of both classically defined waves and particle. So now we have matter being a wave. Is that our aura? Young's original double slit experiment was the first to demonstrate light wave interference. When 2 waves interfere with each other, some of the amplitudes hit exactly opposite on the sine wave graph and cancel each other out, creating no light at all, and then some bright lines and dark line spectrum pattern. That's what happens when 2 flashlights go and interact. They create bright, dark, because some of the waves are the same and they make a bigger wave and that's bright. And some of the waves are down here, oops, like this, and they cancel each other mathematically and go there. Okay, so here's an example of it. The constructive interference is the resultant is the red wave, and the destructive interference, the resultant is the flat wave, no light at all. Okay, I think I can keep going. Here's the experiment. Young put the light on one side of the screen with 2 slits in it. Oh, I have nope there because that's what we expect. The expected results were that when the light passed through the slitted screen, the pattern would produce exactly the same shape as the slits. And this would prove the particle nature of light. But what happened was the one that I say, yep, what happened was that the light passing through the 2 narrow slits created a pattern on the distant screen, bright and dark shapes. Young proposed that light is a wave in opposition to Newton's idea that light's made of particles. Sorry, it sounds like history, but in 1927, okay, so think the idea of matter and matter waves was born. We know about light waves and sound waves, but now we actually have matter waves, but we don't think about that very much, but it's coming out. Think about matter or a human body refracting or bending through a tiny slit. We could do it. That really spearheads the limited conceptions we have about the form. Okay, so the original experiment was done in 1801 and we're just catching up with it centuries later. In 1927, it was demonstrated that electrons show the same behavior, later atoms and later molecules. So that's where we get the matter waves. This means that matter can have properties like light, dispersion, matter, us. Light, we can have dispersion. We can make ourselves bigger, go everywhere. We can reflect, we can refract, bend, we can interfere with each other, our auras maybe, and we can have resonance. All right, so that's interesting. Now, in 2013, experiments demonstrated double slit interference using single electrons. Oh, I already said that, right? Yeah, and they behave, I don't want to reread something. Oh, yeah, okay, finally a single electron is shown to behave as a particle when it needs to be a particle. Oh yeah, and it's with spin and axis, and a wave when confronted with velocity and momentum towards the slits. Instead of splatting, one electron travels through 2 slits. So the double slit experiment demonstrates the fundamentally probabilistic nature of quantum mechanics as it relates to the micro and macro worlds, and the limitations of the ability of the observer to predict experimental results. We just don't know something will happen until it happens. But that said, when I go to work on a person with prana, I'm 100% confident in the results. So I positively knew that we would move that hurricane. We just had to do it. These kinds of observations give evidence that prana is not an electromagnetic particle wave and not a quantum wave particle. Is this based on inference in the physical world and on devotion to the teacher and the teachings, which gains trust? So why do we go in knowing it's going to work? That's what I'm asking. And maybe it's based on inference because it always works. It does work because we first start off slowly, like here's the prana, and then we get bigger. Anyway, we can test all that. So here's another view. It's a nice view of the double slit with one more thing added to it. The top picture is normally what happens, one slit. The middle picture, when one particle or macro object, like a fullerene, which I'll show you that in a minute, molecule goes through two slits, it behaves as a wave. It makes that pattern there in the middle one. The bottom picture, when you put the sensor, and there's a really light arrow from the word sensor to the bottom picture on the red plate, is placed at the slits. When a sensor is placed at the slits to observe which hole the one particle actually goes through, the one molecule goes through, or the one atom goes through, the interaction of the observation collapses the wave function. You're going to know what that means. And the object behaves as a particle again. So the one particle goes through two slits when it's being observed. But if you put on this middle one, if the one particle goes through two slits, it acts like a wave. So really weird. So when we don't look at an object projected on a screen, it behaves in one way. And when we look at it, it behaves in another way. Welcome to quantum physics. Okay, here's Heisenberg uncertainty. The more precisely the position of a particle is determined, the less precisely is momentum. Momentum is velocity times mass, can be predicted. Werner Heisenberg, Jewish German physicist, wrote the uncertainty principle mathematically in 1927. He wasn't kicked out by the Nazis, he was promoted, nor did he attempt to escape. He did not produce any physics that would help Germany win World War II with weapons technology, even though the scientific community believed he could. There is a true story movie about an event where Heisenberg was almost murdered during World War II by a USA Major League Baseball player turned spy called The Catcher, if you're interested in that. The precise values of multiple physical descriptors cannot be known at the same time for quantum particles. There is a limit to what we can know about a quantum system. Measurement does not mean a process in which an observer takes the measurement, but rather an interaction between the classical and quantum objects regardless of an observer. And I'm going to show you what that is, because that right there is a difficult thing to understand. The uncertainty principle is not to be confused with the observer effect, which we just looked at in the Young experiment. When we look at it, it changes, which states that measurements of systems cannot be made without affecting the system in some way or changing it. Applying the observer effect, no measurement is completely accurate. The uncertainty principle is not a statement about observational success. It's a fundamental property of quantum systems. Heisenberg uncertainty is contrary to classical physics, where any number of properties can be measured simultaneously and with accuracy. Oh, here's the experiment. So it's an updated experiment. So here's 3 green lasers. There's a plate there that it's hard to see, but where the yellow arrow is, there's a square plate. And inside the square plate at the bottom is a tiny hole. The middle plate has a bigger hole and the top plate has the largest hole. And they put a laser, coherent green light through. Okay, I just showed you that. Now, what happens on the screen where we're catching it is the pattern. You can see the interference of the light and dark, but the pattern for the small hole is larger. The pattern for the medium hole is medium, and the pattern for the large hole is smaller. So this is what Heisenberg figured out. We expect to see a scatter plot being the same size as the hole. Small hole equals small scatter plot, but the results show the smaller hole, the larger the scatter plot. This means the more precisely we know the location, the smaller hole, we know more where it is. If we measure it at the hole, at the yellow arrow, the less precisely we can know, because we have a bigger area to measure between the black lines, the black arrows. That's what it's all about. And the momentum describes where the photon will land, because right at the hole, it has to decide where it's going to go, because the light goes in a straight line. So it's going to go right in the center, or it's going to go over here, but they all land at the same time. So the one that moved here is moving less fast. The one that moves here is moving more fast, more distance, if you can see it, if you can remember that from geometry. So this speeds kind of change. I think I explained all these notes. Experiments with super small holes, allowing only one electron to pass through, give the same results. Applications that depend on the uncertainty principle are superconducting, quantum optics, and gravitational wave interferometers. Here's another view of it, which is, I think, better. I put these arrows in. As the location of the photons gets more precise at the red arrow, smaller and smaller, the momentum gets less precise at the big arrow, right? That's what the Heisenberg uncertainty principle is all about. But it doesn't mean just for location and momentum. It means for any two quantum descriptors. Schrodinger's wave equation, I like Schrodinger. All conventional physical processes governed by the Schrodinger wave function. But hey, Schrodinger's wave function equation describes what happens in quantum systems, but it just says here that it governs all physical processes, but it also describes what happens in quantum systems. So now we have the subatomic particles becoming microparticles becoming macroparticles, and our 21st century scientists are creating applications that rely on matter being quantum particles. Erwin Rudolph Joseph Alexander Schrodinger, that's when he lived, an Irish Austrian theoretical physicist, contributed to the wave theory of matter. Remember, not of light, of matter. He wrote the Schrodinger wave function in 1925 at the University of Zurich after serving in World War I. He took an appointment at the university in Berlin, and Einstein was there and other smart guys. As the Nazis rose to power in Europe, he left Germany, joined the faculty at Oxford, yay, and ended up as head of the School for Theoretical Physics at the Institute for Advanced Studies in Dublin for 15 years. He stayed there and he survived. His hobby was philosophy and metaphysics. That's why I like him, as evidenced by his books, What is Life, about genetics, Nature and the Greeks, about scientific view, and My View of the World, inspired by the Vedanta, however you say that, or The End of the Vedas, specifically addressing knowledge and liberation. We're just going to keep moving. Okay. Schrodinger was known for his extraordinary intellect, pursuing science as a unique tool to unravel mysteries of human existence. And I think that's what we're doing with Prana. We're unraveling mysteries. Newton's laws tell us exactly mathematically how high, how far, what speed, how much time, and all the other physical measurements that a bouncing ball could go. But the Schrodinger wave equation replaces Newton's laws and the conservation of energy for quantum particles. It predicts analytically and precisely the probability of events actually occurring or outcomes. So remember the puffball, the electron could be here or there or anywhere. Well, we're getting to that. It's just a probability of where it could be. There's the equation. It doesn't matter about that. But Planck's constants in there regarding energy of quantum electromagnetic radiation divided by frequency, and the psi is in there representing the wave function. And those sound very sciencey, but we also have particle mass. So we got quantum variables and particle and Newtonian variables. Mass, we have Cartesian, the C is for the Cartesian coordinates. There's potential energy and time. And those are very Newtonian, objective and very realistic, relativistic. Okay, so now we get into the wave collapse postulate, which is what I really want you to know about Schrodinger's wave equation, not the other stuff. For example, I win the Florida lottery on this Saturday night. That's an event that's going to happen in the future. First, I have to buy a ticket, and then my probability of winning is whatever it says. You can figure it out. And there's zillions of Schrodinger wave functions describing all the different probabilities of all the stuff that could happen of me winning. Some numbers correct, I only win something, or no numbers at all correct, right? So here's a point in space and time, right? Here's a point in space and time that I win. Okay, so I win, but I could be anywhere. Okay, so here's where I win. Here's where I win. Here's this guy. He's obviously an explorer. And then here's where I win, and here's where I win some numbers, and here's where, and these are all Schrodinger wave equations that describe, and they come from everywhere. That's why I said zillion. And they all are at the point of when they pull the, whatever that's called, when they have those balls and they pull the numbers. Okay, so zillions of those. And as the day gets closer, I still don't have a ticket. So the probability of me winning and all of the wave equations start changing. And I get to the parking lot to buy the ticket, but realize I left my wallet at the meditation center, which I've actually done before. And when I went to the airport one time, I don't have enough time to buy the ticket. So the wave equations start changing. All the events of what could happen for the outcome of me winning the lotto is called the wave function probability distribution. All the wave functions, it's a probability distribution. And the different events that are in quantum superposition, this one and this one, this guy has so many different outcomes, right? So they're all on top of each other. Quantum superposition existing in several separate quantum states at the same time, according to the Schrodinger wave equations. Each probability wave has a finite chance, which means like a knowable number chance of being in any one of the superposition states until the event actually happens and all the waves collapse into one wave, the one event that happens in the objective reality, right? See, I can talk about this stuff now with you guys. And when I finally missed the deadline for buying the tickets, all the wave functions that would describe me buying the winning ticket interact with the external world. So here's where observation doesn't matter. It's the quantum states of the Schrodinger wave equations interacting with the external world, and the quantum level and reducer collapse to 1, and the 100% probability comes to be called probability of actualizing and me not winning the lotto on this Saturday. So the one wave function that's left, I miss a day, is what actually occurs. This kind of interaction is an observation or a measurement, or at least an event, even if nobody is there to measure it. It really did occur quantumly or objectively. So it doesn't all, everything doesn't all depend on watching or measuring. Stuff happens anyway. We all say the probabilities collapsed into the actuality of what happened in the real world. What we have got here in Schrodinger's wave equation function is the link from quantum to classical physics and its observables like position and momentum. So when stuff happens that we think is not supposed to happen, like it's not my fault that I'm late to the kid's birthday party and I'm bringing the balloons, quantum physicists understand that no matter how much I try to say whatever with excuses, the probability wave functions were already taking over the outcome or the final interaction with the physical world, and their momentum was too much to overcome. Things happen because they're supposed to happen. Isn't that partially karma or karma? So the Schrodinger wave equations describe everything, and they're a superposition. All right, so to increase, so here we go. To increase the probability of wave functions actualizing at a pranic healing event, it's best to follow the protocols, character building, study, meditation, purification, devotion to the teacher, and the teachings. And that restricts the zillions of possible wave functions to just the ones that are going to perhaps be more successful regarding the areas of pranic healing that are subject to the quantum and Newtonian laws of physics. Now, I start out by saying, is prana subject to the quantum laws? It carries light. We don't know. It's its own thing. It's bigger, it's better. And do the healing when you're feeling well, right? But then on the contrary, when people ask me, does having long hair help with channeling psychic abilities? And I just say, go ask a Tibetan monk. Because if an angel of God is going to visit you, or prana is going to descend upon you, I don't think it matters if you're sitting in the lotus position or in a ditch covered with mud, right? So no matter what happens, if the prana is going to come, it's going to come. If an angel of God's going to appear to you, it doesn't matter if you're bald or whatever. Okay, so Einstein, Podolsky, Rosen, spooky action at a distance. Here's the three guys. Albert Einstein was a German Jew, Boris Podolsky, a Russian Jew, Nathan Rosen, an Israeli Jew born in Brooklyn. They all came to Princeton, New Jersey, running from the Nazis. And they worked at the Institute for Advanced Studies which was formed after the one like was in Dublin that Schrodinger worked at. So just a couple of sentences about the Institute for Advanced Studies, because I hope that's where we're going. Was founded by Abraham Flexner, an American educator, and funded by the Bambergers philanthropy within the following framework during the rise of fascism in Europe. Throughout, this is a quote, throughout the whole history of science, most of the really great discoveries which have ultimately proved to be beneficial to mankind have been made by men and women who were driven not by the desire to be useful or to make money, but merely the desire to satisfy their curiosity. Speculative research, the kind that is fundamental to the advancement of human understanding of the world of nature and of humanity, is not a product that can be made to order. Rather, like artistic creativity, it benefits from the special environment. So they built this special environment called the center, I must say it somewhere. Flexner's guiding principle in founding the Institute was the pursuit of knowledge for its own sake. The faculty doesn't teach any classes, there's no degrees, there's no experimental research equipment, and research never contracted or directed. It's left up to the individuals to do what they want. This institute played a key role in the transfer of intellectual capital from Europe to America during this time, and it's still operational in New Jersey. In 1935, EPR first revealed a mathematical observation of spooky action at a distance, an unexplainable way that particles communicated with each other instantaneously across distance to affect their measured properties. These actions could not be present if the local realistic theories applied. Something was wrong with quantum mechanics. A series of thought experiments and calculations followed, arguing that the theories of quantum mechanics were incomplete and included hidden variables yet undiscovered, or that Einstein was wrong and quantum physics violated realism. Niels Bohr published a paper. Bohr and Einstein used to argue. Niels Bohr published a paper in the same year that started a prolonged debate between Bohr and Einstein about the fundamental nature of reality. Bohr believed that the measurement process was not a simple discovery of a pre-existing property. This was an important scientific meeting of the minds because reality and the theories that rule it were at stake. They were going to have to throw out Newtonian mechanics, for example. Locality, separability, light speed as the maximum speed of everything, and determinism, the idea that identical conditions must always evolve with time in the same exact way, which we know that's not true when we do pranic healing. We follow the protocols, but it doesn't work the same way that it did on the other guy or whatever. So we know determinism, it's not really true, but they were all put to the test through experiments and mathematical calculations. All right, enter John Stuart Bell. Bell's theorem is now known as one of the most profound discoveries in all of physics. He and his wife were employed at the Swiss Particle Accelerator Lab in CERN as particle physicists from 1960, and they were known as longtime vegetarians since teen years. Yay. His wife said he was an atheist, although his mother said he was Anglican. He was from Ireland. Oh, he was born in Belfast, Ireland in 1928 and graduated from Queen's University 48 and got a PhD, and he died in 1990 of a brain aneurysm. Okay, so now, since he grew up in Belfast in the first half of the last century, he was culturally highly influenced by religious thought, including Protestant predestination and God's providence. So his mom said he was a Protestant, which was like maybe a Episcopalian or a Presbyterian. In 1985 BBC radio interview, Bell summarized one of the possible ways to address his the theorem for those who are not willing to give up reality. He called this alternate view superdeterminism, reminding me of predestination and providence. Here's the quote: "There is a way to escape the inference of superluminal speeds, faster than the speed of light events, and spooky action at a distance, but it involves absolute determinism in the universe, the complete absence of free will." That's like hits me in the face. Suppose the world is super deterministic, with not just inanimate nature running on behind the scenes clockwork, but our own behavior, including our belief that we are free to choose to do one experiment rather than another, absolutely predetermined, including the decision by the experimenter to carry out one set of measurements rather than another. In superdeterminism, the difficulty disappears. There's no need for a faster than light signal to tell particle A what measurement has been carried out on particle B, because the universe, including particle A, already knows. So the universe already knows because everything is super predetermined what that measurement will be and what the outcome will be. So he was saying this on the radio to the general population, to everyone. If you don't want to believe in quantum physics, then you must believe in superdeterminism. And his nighttime hobby was quantum mechanics. He was a particle physicist at CERN, but he on his own and his wife were studying quantum mechanics. In '64, he took 1 year off from CERN and visited Stanford, where he wrote his first paper attempting to support EPR, but ended up proving Einstein wrong on superluminal speed, locality, and realism. So Einstein was the first guy that wrote papers and wrote documentation on faster than the speed of light, locality, and realism. Bell wished for a more rigorous proof and was able to provide one in his second great paper that same year. He wrote the first draft of the paper during a stay at Brandeis University in Massachusetts. I don't know where it is, but maybe some of you do. And completed at the University of Wisconsin at Madison, also too cold there for me. There's the inequality. It's really easy. The C stands for the correlation of functions, and A, B, and C stand for the axis spin angles, 30, 60, 90, up and down. That's the original equation. Okay, we can go on from that. So here's the apparatus. So this is the big deal that I think is important for us. We have to think about what this means for our prana work. In the box, the blue box is two particles, and they know each other. They have to share a space. They're inside of a space. He called it the influence of knowing, and we now call it quantum entanglement. Two particles are together. Step two is the particles are shot out to the screen and simultaneously measured for their angles, their spin and their angles, up, down, 30, 60, 90. And then again, Master Glenn, you already know about this. And then the third thing is the particles simultaneously are measured. Oh, well, I already told you that. So according to local realistic theories, the ones that govern the objective reality and Newtonian mechanics, like flipping two coins at the same time, individual coin results should be random. They shouldn't be related at all. But what we find in our quantum micro world experiment here, first as a thought experiment with mathematics, is that if one on one side spins up at a certain angle, the other one on the other side spins down at the other angle. So that mathematically everything produces zero, a net change or balance. And that's a big deal. At the quantum level, everything is balanced. So here he is showing his thought experiment for the first time at CERN. I think his wife took that picture. Why is Bell's theorem so important? That's him giving the first lecture at CERN on his thought experiment with the apparatus. I already said that. Okay. Bell's theorem shows that local realism is incompatible with quantum predictions, so that one must choose between abandoning locality or abandoning realism, or both. We know quantum mechanics is accurate based on all the stuff that we have that we use quantum mechanics for. Think about the space program. We can't throw out quantum mechanics. The math works and math doesn't lie. So we have to throw out local realism. But those who talk about local realism rarely explain what they mean by realism. The experiment conclusively establishes the relativistic non-locality of the actual world. So non-locality means space and time doesn't matter. Oh, that's him as a young guy. We have scientific evidence that certain aspects of the microscopic world transcend human understanding, or that any discussion concerning the elements of physical reality is meaningless beyond the scope of science. So Henry Stapp, another physicist of Lawrence Berkeley National Laboratory, where they have a particle accelerator, called Bell's work on quantum theory the most profound discovery of science. Bell opened up the possibility of experimental philosophy, the study of what was normally thought of as philosophical issues and experiments. Not only do these experiments probe the deepest and most profound aspects of quantum theory, but also provide information on the fundamental nature of the universe, which is, prana is universe and more. The way prana works, how and where we project it, is an example of non-local instantaneous action at a distance. Okay. Yeah, we all know that. So after Bell, the scientific community was at odds still. They had just begun to apply Einstein's great work with relativity, gravity, and space-time, and along comes a thought experiment and some simple inequalities that flip the chessboard and spill all the playing pieces. Actual experiments on Bell's theorem were performed to test the validity of Bell's inequality statements by John Clauser from 69 to 76 and by Alan Aspect in 82 and at the CERN particle accelerator, and will result in proof of high statistical significance. But the argument went on, even though we had the data. It wasn't until 2015 that Bell's theorem failed all the tests with all of the, we said unknown variables, with all the variables, proving that local realism and its components of the objective reality do not hold up to quantum particle tests. We say reality and quantum physics are incompatible. And when I finished my PhD in 1991 in quantum mechanics, Bell's theorem, his work, the arguments, and the experiments were still not addressed in the graduate program or in the physics textbooks. They are now. The failure of Bell's theorem proved that Einstein was wrong about the speed of light limit. He was wrong about locality, and he was wrong that quantum mechanics was incorrect or incomplete. But, you know, Einstein was awesome. John Bell, well, let me see. Einstein won the Nobel Prize in 1921 for his services to theoretical physics, and especially the photoelectric effect. Einstein's energy mass equivalence equation equals mc squared, along with the general and special theories of relativity, opened the door for quantum mechanics. And it is upon relativity and quantum mechanics that modern physics sits. John Bell, in his original thought experiment, along with Bell's many papers following, pushed back against the formalities of the scientific community, proving that we must give up reality as we define it by the local objective theories. If we are to embrace quantum physics and follow it where it leads humanity into the future, we must toss out realism and its trappings of time for our equations.
Zora,
Yep.
Mr. Glenn. What my understanding, I don't know, looks like Bell proved that Einstein was wrong and Bohr was right, if I remember.
Oh,
right?
yeah, the papers, yeah, they were arguing.
The argument between Bohr and Einstein, because of John Bell, people believe that he was able to justify Bohr was right rather than Einstein. The question they have now, it's changing, that when you say in 2015, people feel that it's not true what John Bell was saying.
No, we've tested Bell went out to support Einstein. He went out to support Einstein. But when they tested, when he went to write the equations, it didn't support him. It showed instantaneous action at a distance was true. There had to be super luminous, super faster than the speed of light speeds. So now it's like there was all these, so Einstein, you know, and all the other science, well, there's hidden variables, other things we don't know. So they kept testing and testing. And now by 2015, if you read any research that says John Bell was wrong, it has to be after 2015, because after 2015, he was maybe wrong before 2015, meaning that Einstein was right and that quantum mechanics wasn't right. But after 2015, now it's all true.
So Einstein is, so the debate leans more towards Einstein than Niels Bohr's.
No, Einstein was wrong about superluminal speed. He was wrong about locality and about realism.
Not the debate that Einstein and Bohr was having. What was the 2015 wherein John Bell was?
That's just by the end of 2015. There was enough research all over the place on all the different particle accelerator labs. People were doing all the research that finally we know, here, let's go back to this, just one thing. So finally we know that what he said, proving that local realism components of the objective reality do not hold up to quantum mechanics. So proving that Newton's laws really don't hold up.
Okay, go ahead.
Yeah. Okay, so we have to give up realism, but we're sitting here watching this video, that's real. Or I call it the new realism of the 21st century. We're just getting to it. We know that parts of the universe are actually potentially connected in an intimate and immediate way. That's what we know. Due to non-locality, that's what we know. Entanglement, we know that, we can prove it. And superluminal speeds, which is instantaneous action at a distance, faster than the speed of light, or just not only faster, but just like right now. Our new description of reality. This is where prana operates in the new description, from classical mechanics to quantum mechanics to prana mechanics. The pranic healing mechanics are the protocols in a certain sense. Some pranic healers may like more quantized directions, like project the orange light for 5 seconds. That would be really quantized. But our pranic healing teachers are doing a great job at helping beginners to at least understand the limits that are governed by the feeling of pushback. Maybe not 5 seconds, maybe 2 seconds, maybe 7 seconds. Even if they don't feel it, it's true. So we can't quantize, right now we can't quantize prana mechanics. These are just models of entanglement. So I don't believe that there's tiny strings attached to every particle, to every other particle in the universe, to every particle in the universe in a visible light spectrum kind of way, like the pictures, but I like these pictures. I postulate that it's more likely that excited state prana sent across the planet in MCKS distant healing protocols, for example, or just sent across the planet like Master Glenn can do, rides on the stuff between the atoms, like quantum jumping. The stuff is for now being called dark matter, but it may turn out to be prana, or maybe it really is prana. It has to be prana that fills the universe and therefore allows for existence as we know it today. To Einstein, Schrodinger's wave equation with that collapse and all that stuff, collapse postulate was a stronger retreat from reality or from realism than non-locality. And if nobody, okay, so here's a thing about Schrodinger's wave equation. If nobody, you probably heard of this, if nobody hears the tree fall in the forest, does it make a sound? This is also like Schrodinger's cat. And originally it's a misconception. Really, originally it was given by Schrodinger in lecture to some students about how some conclusions are absurd. So it doesn't apply for everything. The example was grapevined, I called, by students, and misunderstood to mean we don't know unless we observe it or we measure it. Schrodinger explained to Einstein, because they also were arguing, Schrodinger explained to Einstein that the cat example was not meant to demonstrate how quantum physics works. Of course, the tree makes a sound if nobody hears it. And of course, the cat is dead if you do what it says. So I just wanted to clear that up. So now the wave function collapse is not driven by conscious observers alone. Every interaction a quantum particle makes can collapse it. When we pushed the hurricane over, we didn't actually see it. So we weren't observing it. I mean, maybe there was somebody on the radar. And I think afterwards we looked and we saw it was moved. But at the time, we just go ahead and believe that it's going to happen. And that partially is part of what I think makes it also happen. In quantum theory, quantum particles can exist in a superposition of states, like me winning the lotto example, at the same time and collapse down to a single state upon interaction with other particles or upon observation or measurement. In Bell's original experiment, particle B sits in superposition, like waiting until particle A is measured. Then particle B instantaneously collapse into a measurable opposite of what A is. So they both go out, they both are sitting there, and then we measure A, and then B hits. Until particle A is measured, particle B is both up and down, and the same for particle A. Until it's measured, it's a superposition. Could it be that a cell, tissue, or organ can maintain both healthy and unhealthy properties that would respond to the prana push towards repair at the atomic cellular level? Could it be that a cell is superimposed with I'm healthy, I'm not healthy, those tiny little bit of wavelength, those tiny Schrodinger equations that describe perfect health? Why aren't they there? I think they are there. Okay, so here's principles of quantum mechanics, why quantum mechanics must throw out local realism as we know it and make its own new rules. The new rules are non-locality, non-separability, entanglement, and fastness, speed of light. So here's just, I say this in another place, I think too, but Non-locality describes the apparent ability of objects to instantaneously know about each other's state, even when separated by large distances, potentially even billions of light years. That's what the math says. Almost as if the universe at large instantaneously arranges its particles in anticipation of future events. All the Schrodinger wave equations are there. It's just which one is the one that's going to happen. And what we know is that the one that happens is the one that's balanced. Non-separability is a little bit different. Okay, instantaneous action at a distance. Everything is connected. Everything is connected via the quantum field, or what I call the Prana Field, that acts as a carrier to everything. Instantaneous action at a distance is obviously not time-bound. Quantum particles are not time-bound. Prana is not time-bound. And in one of my 89 graduate physics classes, we use matrix math to swing vectors. Okay, so we have this, the Cartesian plane, and we would take vectors and mathematically and swing them out, drop time about out of our equations, and land in the first local dimension, where I said we talk about there's length, width, and time. There's length, width, and height, but no time. And so we've been running the math on getting to the first local dimension for decades. Just why aren't the engineer waiting for the engineers to catch up and make the machines? Okay, entanglement. Particles must share an experience. So, well, I'll tell you in a minute. The influence of not knowing, the influence of knowing to exhibit correlations that are not explained by classical physics or local realism. Entangled particles' mathematical sums, wavelength, frequency, spin, and axis angle, cannot be written as a single product. They have to be written together, entangled particles. It's like they're the same thing in that equation, the inequality of Bell's. If you hypothesize that at the Big Bang, all particles in the universe would experience a single local event, then you could say that all particles are entangled. But the universe, then the universe could be described by one single quantum mechanical wave function. So there could be an extremely small but technically non-zero chance that probability or probability that any given pair of particles is entangled anywhere. Finding these two entangled particles has an extremely low probability and therefore are completely meaningless from a physical perspective. And we have proven that not all particles are entangled. So we have non-separability, everything is connected, but not all particles are entangled. In addition, physics has come across an unexplainable phenomenon known as sudden death of entanglement, where for no reason, two formerly entangled particles suddenly become unentangled. And the last one is about light speed. For now, we know that the interaction between entangled quantum particles is faster than the speed of light. Faster than light, FTL, faster than light speed, has been measured. Faster than light speed, the transmission of information or matter faster than light, faster than C, measured at least 10,000 times faster. It's been measured at 10,000 times faster than C at least. From the Bell original inequality experiment apparatus I showed you, the instantaneous action at a distance faster than light speed is explained by unknown superluminal communication of some kind through an unknown medium of some kind. So yeah, like I said, welcome to quantum mechanics. Okay, non-locality. Oh, back to this guy. A split second, oh wait, back here. A split second after we find, look at the red arrow, after we find the particle at location A, we expect to find the same particle at the next or nearest adjacent location. Master Glenn has talked about this. We believe this because we are stuck in time, and travel requires a speed as distance over time. A split second after A is found, pointer B finds the particle at the blue arrow. It's supposed to be somewhere around A, but if we check it and we look for it there it is. No matter where we point the arrow and look for the particle, there we will find it. Anywhere in all of those puffballs. How can this be possible? In order for the particle to move from A to B, the distance must be traveled in a certain time, miles per hour, for example. For quantum particles, the movement can be instantaneous or require no time at all. Not just faster than the speed of light, but no time at all. Okay, instantaneous action at a distance. Einstein's spooky action at a distance. What the EPR guys talked about is what that is. The locality or location of the particle doesn't matter anymore. That's non-locality. That's one of the things that we rely on quantum mechanics: non-locality, non-separability, entanglement, and faster than light speeds or instantaneous action at a distance. But the electron is not a particle at all. It's a puffball of energy responding to the pointer that measures the whole of the electron wherever it points. Remember, it's a puffball. The electron is everywhere inside that red circle. So anywhere we point at it, it's going to come up. It's kind of weird, but the electron is a particle. Oh, so it's not a particle, it is a particle and or wave that does not behave like one according to classical physics. The particle and wave properties and corresponding wave functions are superimposed, remember, over each other, one version until the other one is needed. One can understand this multiple existence like the etheric body being superimposed over the physical body. We get that, right? Quantum physics and the study of prana support each other. That's my mind. Okay, non-separability, to try to understand that. Non-separability and non-locality together describe the apparent ability of objects to instantaneously know about the other state, even when separated by large distances, billions of light years. That's Bell's experiment. Almost as if the universe at large instantaneously arranges its particles in anticipation of future events. Does it? That would be Bell's superdeterminism, if the universe was doing it. We don't actually know what's doing it. Okay, separability, locality, and speed of light have always been necessary for relativity. So relativity relies on those three things. And we conclude that relativity is also incompatible with quantum physics. So realism, Newtonian mechanics are incompatible with quantum physics. Relativity is incompatible with quantum physics. That's why Einstein was banging his head about it. No experiments are needed to prove this. Relativity is all about where A is compared to B relative to another object or event, like the Doppler effect, the two guys and the horn honking here and it moving. In quantum physics, position, okay, so in quantum physics, position doesn't matter. Position can change instantaneously. We don't account for relativity in quantum physics because position doesn't matter, except in the definition of entanglement, where particles must be relatively near each other, have the influence of knowing, or have been created during the same event to be entangled. Again, parts of the universe, I already said this, but parts of the universe are actually potentially connected in an intimate and immediate way. So is this karma gained from planet Earth herself, from identifying with nationality, city, and our family, etc.? In the picture, it's impossible to tell where one particle energy field ends and the other begins. So they came from the same event, so they're entangled. So superluminal, faster than the speed of light. Classical mechanics, no physical effects can move faster than the speed of light. That would bust out, that would dissolve relativity. Bell's theorem proved that particles connected through quantum entanglement communicate information faster than the speed of light. There exists interactions between events that are too far apart in space and too close together in time for events to be connected even by signals moving at the speed of light. So we just know it's true. For now, we know that the interaction between entangled quantum particles is faster than the speed of light. And I say prana changes state because my understanding of prana is that it's already everywhere and actually does need to be projected or travel across distances over time to go from Tampa to Anchorage. So it can go there from Tampa to Anchorage, but it doesn't need time. As soon as I intend it to be somewhere or be doing something, it's already on it instantaneously, prana. It's like what the rabbis say in the Mishnah about God's light. You don't have to summon God to be somewhere at some time. He's already there. The light stands ready to overcome the darkness in an entangled, non-local, and faster than light or instantaneous kind of way. For now, we're finding it useful to use our hands for scanning and projecting prana, but the hand is merely a prop, maybe, for our sake because we cannot understand what prana is or the power that it actually wields. Prana is pretty awesome. Wang Yin, a Chinese physicist, has measured the speed of light at the minimum of 3 trillion meters per second. That's a minimum limited by his equipment. So just briefly, in case you want to talk about it to somebody, is that at the University of Science and Technology in Shanghai, they took 2 entangled photons 15 kilometers apart across the Qinghai with a Q lake in the Tibetan plateau. 2 entangled particles they placed there, 15 kilometers across. They measured the first photon and then timed how long it took for the second photon to be influenced by the measurement and change its properties to match the first proton across the fish farm. So 3 trillion meters per second, 10,000 times faster than light was how long it took for the 2 entangled photons to communicate. Their testing equipment and methodology simply didn't allow them to get any more accurate results. The communication between the entangled particles may probably turn out to be instantaneous. This first observation of superluminal speeds in our time is a significant event for scientists everywhere. We know that quantum entanglement can be used to realize quantum teleportation superluminally. Oh, entanglement. Okay, so in quantum entangled particles enables particles to affect each other instantaneously across distance. So I'm hearing people saying everything's entangled. Everything's not entangled. It's this. It's just they have to know each other. They have to be entangled, and then they can affect each other's properties. They can change their actual position on the material level. Entangled properties would remain connected even if they were on opposite sides of the universe. So particles that interact with each other become correlated or dependent on each other's states and properties. That's just a little picture. Using quantum mechanics, we can say what is going on during entanglement events, but not why, right? Entanglement, not just particles, small macro objects as well. 100 years after relativity and quantum theory, physicists are full on into the process of thought experiment, mathematics, and physical experimentation. We're looking straight at engineering, creation, and building of the machines from research and development using the principles of quantum theory we've just reviewed. Quantum entanglement has been demonstrated experimentally with photons, neutrinos, electrons, molecules as large as buckyballs, and even diamonds. So here's a buckyball in case you forgot. It's that one that they used to make toys and big, and then somebody got hurt. That's a buckyball. It's a chain of 60 carbons with a hollow center. An example of it is shungite. It's a hard rock, or it's a hard stone. And some stores that sell stones, they say it's used to collect EMF, electromagnetic fields, around household objects like the computer or the router box. The EMF is stored in the center of the buckyball or the fullerene. So says somebody who has knowledge about that stuff. So that's named after Buckminster Fuller. And then a diamond, we've done it with diamonds too. We've done all this stuff with these 2 guys, C60 and C8. Diamond crystal of 8, the first one's in the middle. It's a square within a square within a square. So you can see why diamond is so sparkly. Yeah, it's about the cut, but all the faces of the squares truly cause the hyperreflective property of the diamond. So we've done superluminal speeds with these guys and all that stuff. That doesn't matter. Position doesn't matter, time doesn't matter. Entanglement and non-locality effects are very active areas of research and development and communications, computation, information, radar, heat, engines, and teleportation. Here's a quote, two sentences from some papers. Quote, it is possible, is it possible that entangled objects lose their individuality and can only act as a single paired entity, bringing to mind human relationships of love, end quote. Interesting. That's from a physicist. Another quote from another guy. Could quantum entanglement be responsible for anomalous events such as spontaneous healing? What? Interesting, end quote. Interesting, this paper called spontaneous healing anomalous, meaning not normal. But it's a physics paper writing about healing, so we'll take it. Okay, so here's some stuff going on now, and we're getting pretty close to being done if you're getting tired. Anton Zellinger, he's the guru now. He's the new Einstein, the new Bell. is an Austrian quantum physicist and president of the Institute for Quantum Optics and Quantum Information at Austrian Academy of Science. And he was born in 1945, yay, after all that mess. Most of his research concerns applications of entanglement. Thank you, Albert Einstein and John Stuart Bell. In 2013, he proved that non-locality applies not only to space, but also to time. So it means that 1 second, like a first second A, and then there's a second B. The second B doesn't necessarily need to happen after the first second because time doesn't matter. Second B could happen anytime, relative or not relative to second A. Time is non-local. Space is non-local. What are the implications of this verified time travel ability for us using prana to heal physical, mental, astral, and etheric trauma? What could we do with that? We know that in 7 years or so, every cell in the body replaces itself. That's not what I'm talking about. But since linear time doesn't matter anymore, why couldn't we start healing using that knowledge? I don't know how we could do it, but we should be able to do it. Time marches on, or does it? You know, is time linear? Guess not. Zellinger has held research and teaching positions all over the world at MIT, Innsbruck, Oxford, Munich, Paris. The big research institutes all wanted him, but he went back to his home in Austria and opened up the big institute there. He started winning prizes in '75, and he won the inaugural John Stuart Bell Prize in 2017 for his contributions to quantum mechanics and applications. This is the beginning of the answer to the long time question. Since quantum particles or the micro world make up literally everything in the known universe, why don't macro objects like bouncing balls obey the same quantum rules? Well, we're finding out, yeah, they do. Zellinger's experiments are proving that quantum mechanics do indeed rule macro particles. No location, no time is needed anymore. As the engineers catch up to and build the machines, it's going to get really weird. But we're ready for it because we have the mindset, all us pranic guys, because we already know things are out there. Zellinger wrote and realized by experimentation the first quantum computing protocols, including teleportation of an independent qubit, entangled swapping, teleportation of an entangled state, hyperdense coding, and quantum cryptography. He did all that stuff. And quantum computing, a qubit is a quantum bit. It's a sphere of 0.2 millimeters across, so that's actually measurable, and made of silicon. So qubit is a silicon tiny little ball. It can carry information like classical binary units 1 and 0. One qubit can be encoded with lots of pieces of classical information. So in 1997, we're still talking about Zellinger, teleported qubits across observatories in 2 Canary Islands using entanglement. He did it across the ocean there, across the channel, so he could show he didn't run any fiber, because they were first doing it with fiber optics. But he did it, and there's the picture if you can see it, and that's what an observatory is. His work in the Canary Islands indicates that entangled particles, they have to be entangled first, can be reconstituted in a different place, and has applications for satellite information intelligence, which means spying communications. In 2017, Zellinger and his team constructed and operated successfully a stable and secure quantum satellite between Vienna and Beijing, 4,600 kilometers. Satellites relay data and information. He didn't care about sharing with the Chinese. Scientists don't normally care about that stuff. He is currently experimenting with matter wave interference from neutrons to macromolecules like fullerenes, those balls. We know about light interference and bright line spectrums, right? But matter wave interference, like you and me getting together and our auras interacting, are we talking about matter wave as an aura or as a prana field? That's what we're talking. That is what we're talking about. I don't know what we're talking about, but that's what those guys are talking about. And experimenting. Oh, so he's currently experimenting with matter wave interference and with multi-particle retanglement, resulting in the GH and Zellinger theory that provides the most concise argument between local realism, back to Einstein, and the predictions of quantum mechanics. So 100 years after Einstein, Podolsky, Rosen wrote the paper about spooky action at a distance that inspired Bell, AKA the influence of knowing, AKA entanglement. Physicists are mostly not arguing about reality anymore. Everybody knows that nobody knows. And aren't open-ended questions so very fun? Okay, so these particles in the picture are entangled because they were created from the same source. They interacted together at a wave collapse event at the bottom right, showing the event as a white light. That's not on the screen because whatever. Okay, understand that? I think you should by now. And Zellingers wrote a book called Dan. There he is at age 79 in May, still talking to people. He's a go-getter. All right, so now just some stuff about what's happening. Toshiba, Cambridge, they've built the first fiber optic network. They're transmitting quantum data and normal high-speed binary data. Pretty cool. This breakthrough means that the world's fiber networks, I think I'm on fiber optics here, can now be secured with theoretically unbreakable encryption through the quantum part. I think that's just a picture I was showing you. World's fiber optic network. Yeah, okay. About computers, a bunch of quantum computers are using the properties of quantum states, such as superposition, interference, and entanglement to perform calculations in their quantum computers. Since 2016, IBM, that's a long time ago, 2016, in the science world, IBM and Microsoft have created quantum computers that are experimenting with quantum mechanics and entanglement. And here's the top guys in the field. They're in New South Wales, in Australia, Assad Morello and Mazdik. They have near error free quantum computing that's silicon based, yay. So it works with what we have now. It's compatible with current semiconductor manufacturing technology. And right now it's 99% accurate. So that's 2022. We're just getting there. Now, just a couple of things, because thermodynamics is important to know about this stuff. I think quantum mechanics now is pushing back against the laws of thermodynamics. So we don't have relativity. We don't have Newtonian mechanics. Now we're pushing back against thermodynamics, the second law of entropy and the zeroth law of equilibrium. Just a reminder, really simply, second law is about disorder. That's entropy. If things are left alone, like your room, it will evolve to disorder or higher entropy without adding heat. That's what second law is. The first law, or the zeroth law, is about equilibrium. If left alone, two systems will evolve towards equilibrium. And you understand that, especially here in Florida. We open the door, come in, because we don't want the air conditioner to get out, because we can feel the heat, the cool sinking and the heat. We can feel that mixing, right? Everything's coming to equilibrium. We're pushing back against those. University of Nottingham researchers have discovered that they can extract heat from quantum superposition states. So they can get more stuff because they just go to the superposition states before the event is measured, before it's collapsed. And that's just last year. They're working on, they can get more heat out of what we used to think we could only get a certain amount of heat out of without any more work. A research team at Penn State describes out of equilibrium state, quantum state. Never realizing equilibrium. They just keep it in this non-collapsible event, and then they can keep getting energy from all of the different Schrodinger equations, basically. That's going on now. Well, what this means to people who work with prana is primarily that we cannot say prana will go from a higher density source to a lower density source automatically. And I've heard people talk about that in working with prana. We must always intend or project prana to the entire world. If prana behaves like this, we must always, because if prana doesn't apply to the laws of thermodynamics, if it does its own thing. So we must always intend or project prana to the entire world. I'm just thinking here. For example, in meditation of the twin hearts, or specifically in a need area like war-stricken regions or individuals, etc. Objects obeying quantum physics principles like non-locality, where we never know where something is or where it will be. We only have probability distributions. Entanglement, objects that have interacted in some way communicate their state to affect changes in other states, and superluminal speeds resulting in time not mattering anymore. So objects obeying quantum physics cannot be relied upon to seek equilibrium or to require measurable work to make changes. Second and zeroth law of thermodynamics busted. at the first part of the 21st century that we're in now, research is proving small micro objects are subject to the principles of quantum mechanics. Okay, about oh, this is really cool. At the University of Vienna, scientists were able to take pictures of objects using photons that had not interacted with the objects, but were entangled with photons that did interact with the objects. Okay, so here's an example. I was trying to explain to my husband. So my husband and I are together in the guest room with the door shut, and the photographer's in there. And so we're entangled. And he goes, I stay in the guest room, he goes out and gets in the hot tub. Then the photographer takes a picture of me. And what he finds is a picture of my husband in the hot tub. That's what we've got now, that we can actually do that. They're doing it in Vienna, where, you know, close to where Zellinger is. Does this quantum phenomena partially explain remote viewing or clairvoyance when we apply the notion that time doesn't matter? Interesting stuff. Quantum batteries, tons of them, lots of people working on them. They're being tested all over the place. And, oh, wait, I gotta say this note. Remember the excited state in a photon. Remember that the excited state is when photons are added to an atom and the electrons jump up to the quantum level. When the electrons jump down, it releases a photon or energy. So we're grabbing that energy by moving things up or down. Okay, quantum batteries are being built and tested. I did that one. Another one in Italy, and another different kind, super absorption, another different kind in Australia. They're being tested all over the place. Oh, yay, summary, look. So here's some pretty pictures for you to look at. I think knowing the principles of quantum mechanics can be useful when teaching MCKS classes. I'm not an MCKS certified teacher, but I imagine that a set curriculum is followed. As a general population becomes more aware of the advent of quantum technology into our lives, we should avoid criticism from the scientists and the science-minded people who note misuse of principles when we're talking. For example, all things are not entangled, although there is a quantum field, or perhaps more precisely a prana field, that exists unbroken throughout the known and unknown universe. Prana does not likely follow where needed. That's the thermodynamics and equilibrium, unless you are the hierarchy and intend it to do so. You know, like maybe there's something going on. Obviously there's stuff going on, I don't know. But we think it doesn't, I just want to be careful. It doesn't maybe follow, doesn't go where it's needed unless there's something else going on. It's not like I'm in control of everything. We have to use light and paint colors examples correctly. Remember when I went over that? Mind your words. It's not the red paint or the red wallpaper in a restaurant that stimulates the lower chakra and makes you hungry or whatever. It's the red light reflecting off of the red wall. Okay, it's not that important, but to somebody who actually knows about this, they're going, oh, that guy doesn't know what he's talking about. So then the next thing he says probably doesn't know what he's talking about. So we just need to be really careful, because it's not that hard to look up stuff about what's going on. Prana may fall within the broad terms of quantum mechanics, but prana likely does not comply 100% with the laws. Prana is not a photon, therefore prana is not light. It does not land on the electromagnetic spectrum. It does not have an electromagnetic field or travel at the speed of light. Prana is its own thing. And I know I'm preaching to the choir here. So summary, look, here's some stuff we can apply to healing. I just put this down. Karmas, maybe something about entanglement. Well, for physicists, you know, for science people, prana itself, all these things, I'm not going to read them. Clairvoyance, my voice is tired. And meditation. Let's not forget about resonance and amplitude sums in meditation. Okay, what experiments could we do? I think this is what Allison was asking. Is prana field bigger after the conductivity prayer? So prana field we can measure just by scanning it, but using the, oh, I should have had a dowsing rod here. So if here's my prana field, or you know, my aura, and I use the dowsing rod, it bumps up when you move the dowsing rod this way. If you hold it this way, not this way. If you move it this way, it starts to bump up. Is what happens as you get closer, and it won't even go. Can you see that? So if I am my arm, and here's a person I'm measuring their field with a dowsing rod. I'm holding it. Here's the dowsing rod, and it comes up and it comes up, and I say, okay, project your energy. They can go like that, and it can move. I've done that before in front of people. it's not that hard. It's no big deal. But that's how we can maybe measure the Prana Field. Is Prana Field bigger directly after level 1 activating chakra experience? Why shouldn't it be? Our chakras get bigger. What about height? What about body height? Do we grow a little bit? And then we settle back down. Is there a difference between meditation and thought intention in Prana Field? We just think stuff. Or can frequency increase in front of projecting prana and relatively decrease behind, like in the Doppler effect? Maybe we can measure that. What else can we test using the dowsing rod and linear measurement? Okay, so now objectives maybe to be able to talk to scientists, and wouldn't that be nice? And with evidence of prana, to argue that natural progression of physical science is classical and quantum, and then maybe we're going to all get into prana, facilitate awareness of whatever. And what are our goals? Be successful in producing statistically significant, reliable, and relevant data supporting first the existence of prana and the prana force field. To publish in journals that reach various genres of people, like the New Age people and whoever, super scientists. I've been in the APA. I spoke at their conferences. Let's go there too. How about the doctors? They might want to know. To be accepted by the PHRI as a legitimate research team, and to establish stakeholders and philanthropists at the PHRI. That's New Jersey. That our head of it is sitting here with us to support our research efforts. Okay. Yay. This concludes my presentation. Thank you, thank you, thank you. Namaste, love and peace. And yes, does anybody want to say anything? Otherwise, would Master Glenn please offer a blessing and thanks? If anybody wants to say something.